Okay, good afternoon to everybody. Today is the actually last class for us. Today I will discuss about the sampling techniques and estimations. And this has this plays very important role in statistics, where you are doing research with the taking help of tools from statistics. This is very important for you, sampling techniques and estimations. First of all, sampling techniques. Sampling, what is sampling actually? This is the actually procedure by which some members of a given population are selected as the representatives of the entire population. So sampling means actually we have to collect a sample from a population, then it will treated as a sample. Okay, and if you do any if you apply any techniques for this sample, then it will be sampling. So actually in population there are two part. One is universe and sample. Universe means the larger group from which individuals are selected to participate in a study. Okay, and while sample, the representative selected for a study whose characteristics exemplify the larger group from which they are selected. That means sample is uh, a small group of a universe. Now purpose of sampling, why we will study actually use this sampling to gather data about the population in order to make an inference that can be generalized to the population. Actually this is the whole part, okay, of population. This is the, and a sampling is a small part of population, right? So there is the interference relation between these two. So process of sampling, actually first of all we have to define a population, then develop a sampling frame. We have to make a frame for from that sample, then select a sampling method. We have to select a method to um, examine the sampling or to test the sampling sample. Determine a sample size. We have to first of all we have to determine the size of that sample, then execute the sampling process. Okay, now what's the sampling process actually? First of all you have to define the population, then develop sampling frame from that population. After framing that sample, select a sampling method. You have to select a sampling method, then determine the we have to determine the sample size. Okay, then execute the sampling process. After that we have to execute a sampling process. So sampling and representativeness, actually sample population, this is the whole part of population, and sample, and this small area circle is be the sample, and you have to determine the, and you have to execute this sampling method for this only sample this. Okay, and now target population will be sampling population. This is the sampling population whole part. This is the whole universe or whole population. Okay, then if we target population will be this. Okay, then more smaller circle will give the sample. Okay, sampling techniques, actually fixed versus sequential sampling, and attributes versus variable sampling. That means one is sequential and other is variable. And the another one part is probability versus non-probability sampling. Now there are two parts. One is probability sampling, non-probability sampling. There we have to differentiate these two parts. Every element in the target population or universe. Target population means actually universe or sampling frame, same words, has equal probability of being chosen in the same in the sample for the survey being conducted. On the other hand, non-probability sampling, every elements in the universe or sampling frame does not have equal probability of being chosen in the sample. And in second one, scientific, operationally convenient and simple in the theory. On the other hand, non-probability sampling, operationally convenient and simple in theory. Okay. Result may be generalized, but here in non-probability sampling, results may not be generalized. That means result generalized one cannot be generalized. This one. So there are a huge classification of sampling technique. First sampling method are two types. One is probability sampling method, other is non-probability. And this probability mainly simple random sampling, cluster sampling, and systematic random sampling. Another two parts, we can stratified random sampling and otherwise area sampling. Okay. So on the other hand, non-probabilistic sampling method can be classified categories into two part. One is convenience sampling, another is quota sampling. Okay. Then on the other hand, it can be classified into another two parts. One is judgment sampling and other is other sampling methods. So there is a huge classification for this sampling methods. Now simple random sampling, actually just in lottery method, applying lottery method, we can determine the result of a sample. Tables of a random numbers. This is a very easy and simple random sampling method. Stratified random sampling is another method. Stratified sampling method is a method of probability sampling in which the population is divided into different subgroups and samples are selected from each of them. There are different two steps for this stratified random sampling. First step, one, all units of population are divided into different status in accordance with their characteristics. First of all, characteristics classification, then using another one is using random sampling. Sample items are selected from each stratum. And systematic random sampling and quasi random sampling, this is the actually another important method for sampling method. This is probability based sampling, in which that we defined the target population is ordered and first unit of sample is selected at random and rest of the sample is selected according to the position using skip interval. Every kth item we can classify the item k equals to capital N divided by small n, where k is the sampling or skip interval and capital N is the universe or population size, and small n is the sample size. The sample is the subset of population or universe. This is why. There are multi-stage random sampling. Okay, used in large scale investigations. First stage, preparation of our large size sampling units, then randomly selecting a criterion number. This is the stage of random sampling. Second stage, another list prepared from them, then subsample drawn by random sampling. Cluster sampling, another the process of randomly selecting intact groups, not individuals. Then it will become a cluster within the defined population sharing similar characteristics. There are also two steps. Okay. Area of sampling, what will be the area for sampling to take the samples. One special type of cluster sampling is called area sampling, where the piece of geographical areas such as districts, housing blocks, or towns. Non-parabolic quota sampling. Other non-probability sampling method. This is the non-probability sampling methods. Intensity sampling, homogeneous sampling, criterion sampling, and snowball sampling. There are 4 types. Selecting participants who permit study of different levels of the research topic. This is intensity sampling. And homogeneous sampling is actually the selecting participants who are very similar in experience, perspective, or outlook. Every term are similar. This is why homogeneous. And criterion sampling, selecting all cases that meet some predefined characteristics. Predefined characteristics, that means predefined conditions are needed for criterion sampling. And snowball sampling relies upon respondent referable of other with like characteristics. There are different factors to consider in sample design. Suppose research objective, resources, knowledge of target population, degree of accuracy, time frame, and research scope. Statistical analysis. Okay, first of all, we have to define some definitions for this sampling, which is used in sampling. Population, sample, parameters, statistics, census, and sampling. Okay. What is population? You must know all items that have been chosen for a study. It is called census. In previous slide, we have seen what is population. Sample also it is a part of population. Parameters, characteristics that describe a population. Okay. Statistics, characteristics that describes a sample. A relation between parameters and statistics. What is census? Process of obtaining responses from or about each member of the population. And sampling, the process of selecting a subset from the members of the population. This is very important definitions. Now, convention to be used. The parameter used in population and parameter used in sample. Size, capital N, small n, mean, mu, and x bar for sample, and mu for population. We have studied about this in our test of hypothesis also. Standard deviation, sigma, and S is for sample population, and population for sigma. And proportion will be p or pi, and this will be p bar or only p. Sampling methods, non-probability sampling method, probability sampling method. We have seen this. Now there are different types of sampling. Simple random sampling we also have seen in our first slides. Simple and random samples have merits and demerits also. Systematic sampling, stratified, we also seen in our previous slide. Sampling distributions. Actually, sampling distribution of the mean, it is a probability distribution of all the possible means of the samples is a distribution of the sample means. For example, suppose our sample each consists of 10 25-year-old women from a city with a population of 1 lakh. By computing the mean, height, and standard deviation of each these samples, we would quickly see that mean and standard deviation of each sample would be different. So there will be a difference between mean and standard deviation. If you take this sample 10-25-year-old, okay, from 1 lakh population, if we find out the mean and standard deviation, then there will be difference between these two. So sampling distribution, population, sample statistics, sample distribution. Okay. If you take population, all professional basketball teams as a population, then there will be group of 5 players. It will be samples, for example. The sample statistics will be mean height. Okay, mean of height, and a standard deviation of mean will be sample distribution. There are 4 columns. And in sampling distribution, the sampling distribution will depend on these 3. Okay, so population sample will come from population.
স্যার আপনি
And
স্লাইড যেটা পড়াচ্ছেন সেটা সম্ভবত শেয়ার করছেন যে সেটা না মনে হয় স্যার।
okay, this one, right?
এখন ঠিক আছে স্যার।
Yes, sir.
Okay, okay. Sampling distribution, for example, this is for population, sample statistics, and sampling distribution. Okay, so all professionals basketball are the population, and if you take sample from the population group of 5 players, and sample statistics will be mean of height, and sampling distribution will be standard deviation of mean. This is the sampling distribution. Now if you take another example for a population, all parts produced by manufacturing process, suppose I have taken 50 parts, from that whole parts, then this will be sample, and sample statistics will be proportion defective. Okay, proportion defective, and standard deviation of proportion will be the sampling distribution. This is the example of actually sampling distribution. Now what is a sample distribution? Let's create a sampling distribution of means. You take a sample size of 1,500 from the US, record the mean income. Okay, our census said that the mean is $30,000, mean $30,000. This is the sample mean. A sampling distribution, this is for 2 samples from 3, 4, okay, 5, and etc. will come on. This is the, now this is the actually the sample mean would stack up in the normal curve. This is actually a normal curve. Okay, this is the curve. This is the, we have used a normal distribution, Z distribution, T distribution, F distribution in test of hypothesis. Okay, we got these types of actually curve, but these types of curve is called normal distribution curve. So say that the standard deviation of this distribution is what, 10 kilo. That means $10,000. Think back to the empirical rule. What are the odds you would get a sample mean that is more than 20 kilo off? That means we got 10 because there was 30 kilo. This way $20,000 is off. We observe this from normal curve. This is the left tail, and this is the right tail. It start from 0, 1, 2, 3, etc., and -1, -2, -3. So this is the right tail test, and this is the left tail test, 2.5% here and here. So this is the geometrical interpretation of normal sampling distribution. Okay, standard error. Actually, what is standard error? The standard deviation of the distribution of a sample statistic is known as the standard error of the statistic. Okay, sample error indicates how spread out disappear the means of the sample are, and sample error indicates not only the size of the chance error that has been made, but also the accuracy we are likely to get if we use a sample statistic to estimate a population of a parameter. So you have to remember this standard error. Now the relationship between population parameters and the sample distribution of the sample mean. This is the actual expectation of mean x bar equals to mu x bar equals to mu x. So is equal to the population mean. Understand? This is the mean of population, remember it. And the variance of the sample mean will be sigma square x. This is the sample mean, sigma square x divided by n. That means it is equal to the population variance divided by the sample size. You have to divide with the sample size. Now the standard deviation of the sample mean known as the standard error of the mean. Okay, Standard error will be denoted by standard deviation of the mean is equal to the population standard deviation and divided by the square root of the sample size. Okay, you have to remember this formula. Now central limit theorem, actually sample size, depending on sample size, what we have to uh, apply the distribution. Now conventions to be used, size will be this, you have seen earlier. This is the parameters for population, this is the parameter for sample. Now working methodology in jet distribution. First of all, if you have to check the sample size. If the sample size is n is greater or equal to 30, then uh, then we have to apply the z score using this formula, z equals to x minus mu x bar divided by mu x, where x is the sample mean, mu x is the mean of sample. Okay, this x bar is actually in down. Okay, in down, not multiplication, this mean. So mu x bar equals to mu, and sigma x bar equals to sigma divided by root n, root over n. This is the practice problem for you. For finite population multipliers, you have to use this formula. And if the size is 5% significant, the population is finite. If less equal to, the population is infinite ratio. This is the practice formula. Now what is estimation? When you are ready to cross the street, you estimate the speed of the car that is approaching towards you. Understand? When you cross the route from one side to other, suppose a car is coming to you, but you have to go to the other side of the route. Okay, then what will be happen to you? Actually you have to estimate the speed of your car. Okay, when you are ready to cross the street, you estimate the speed of the car that is approaching towards you, the distance between you and the car, and you own speed also. Okay, then based on these quick estimates, you decide whether to wait or walk or run. Okay, this is the actual estimation of a real life example of estimation. The reasons for estimates: unit had estimates of next year admissions. Okay, credits manager estimates whether the purchase will eventually pay his bills or not. Homemakers estimates about the increase in commodity price. Homemaker. And you are estimating that your final results will increase your number. That means you'll get a good result for in the final examination. This is your estimations. Now types of estimations. There are first of all two types: point estimate and interval estimate. What is point estimate? A single number that is used to estimate an unknown population parameter. Okay, interval estimate will be range of values that is used to estimate the unknown population parameter. This is the unknown population parameter. Okay, but it is a single number, but it will be range. For example, department head makes an estimate that our current data indicate that MBA course will have 300 students in the next year. Okay, this is the estimation. Next year, 300 students will be admitted to MBA course. For example, interval estimate will be department of head makes an estimate that our current data indicates that MBA course will have 282 to 320 students in the next year. This is the interval. Okay, 280 to 320. This is why it is called interval estimate, and this is the point estimate, only 300 depending on. So it indicates the errors in two ways. Actually, will be two ways of error, often insufficient as it is either right or wrong. Okay, evaluation of precision of estimators is not possible. It indicates errors in two ways: extent of range. Okay, probability of true population parameter lying within that range. Now estimators and estimates. An estimator is a sample statistic used to estimate a population parameter. Sample mean, estimator of the population mean mu, and sample proportion P bar can be estimators of the population proportion P. This is the sample estimator. If you want to classify, suppose population in which we are interested, these population parameters we wish to estimate, and sample statistic we will use as an estimator. This one, an estimate we have make. So employees in a furniture factory, this is the population in which we are interested, and population parameter mean turnover per year, mean turnover for a period of 1 month. This is the sample statistic estimator. Estimate we 8.9% turnover per year. This is the example of estimate we make. Similarly, teenagers in a given community, proportion who have criminal record. This is the population parameter we wish to estimate. An estimator will be proportion of a sample of 50 teenagers. We have taken just 50 teenagers, and this is the sample statistic we will use an estimator. An estimate will be 2% have criminal records. This is the estimate we have made. Characteristic of a good estimator. Actually, there are two characteristics. It should be unbiased, it should be efficient, and it should be consistent. Okay, and it should be sufficient. So this is the practice problem for you. And in its interval estimate, interval estimate range will be given. Okay, confidence level also will have confidence level and confidence interval also, like this. This is the sample mean, and z sigma x bar, this is the standard error, remember it, less equal to mu less mu is the population mean, less equal to x bar plus z sigma x bar. Okay, this is the left tail and this is the right tail, and this is the confidence coefficient z. Z is the confidence coefficient. So if the confidence level is this 90%, confidence coefficient will be this 5%. This is the 10% significant, 5% significant, 2%. This is the confidence level. So how to computation, the computational procedure, suppose for Z transform, we can use this formula, sigma square root over summation x minus x bar whole square divided by n minus 1. We have used in our test of hypothesis. Actually, this is the practice problem. This is the T distribution we have discussed in our previous lectures. Understand? This is why I'm not repeating this. Okay. Now the decision flows are estimation. Actually, if we start with the sample, if sample size is n greater or equal to 30, then we can use z transform. Okay, if then is a pop known to be normal distribution. Okay, then use a statistician. This or otherwise is a standard deviation known. If yes known, then zx statistics. If not known, then t statistics. Okay, so population mean, sample mean is this, mean of a standard deviation method, sampling method, this the parameter. Okay, now start the some sampling method. Okay, what is population or universe? We have known, sampling known, parameters also. This is the population parameter symbols. Okay, this is the sample statistic parameter and symbols. Types of sampling we have studied. Actually, sampling distribution, expectation of x and variance of x. We have studied this from slide. Now try to study some examples related with this. Suppose example 2, a cubical die was thrown 9,000 times. How many times? 9,000 times. And this is cubical die. and 1 or 6 was obtained 3120 times. 1 or 6 these times. Can the deviation from expected value lie due to the fluctuations of sampling? Now let us consider this hypothesis that the die is unbiased. One hence the probability of obtaining 1 or 6 will be what? Favorable sample divided by total sample. In one die, how many samples total? 6. And our favorable 1 or 6 means what? Favorable sample 2. This is why probability of obtaining 1 or 6 will be 2 divided by 6. This equals to 1 by 3. So probability of success will be 1 by 3, and probability of failure will be what? 1 minus p. 1 minus 1 by 3 what? 2 by 3. Okay, because total probability p plus q equals to 1. Now the expected value of the number of success, expected value of the number of success is np. Okay, np, this is the formula for mean. So 9000 and sample size, and p is the 1 by 3 probability of success. This is the total. Also sigma, standard deviation, is equals to square root over npq. This is the formula. So just putting the values, we get 44.72. Now 3 sigma equals to what? 134.16. So actual number of success 3120. Okay, this is given success. Now difference between the actual number of success and expected number of success. Expected number of success what? 3000. Okay, right? We have calculated 3000 success, but actual given 3120. So 120, which is less than 3 sigma. Okay, 3 times less than. Hence the hypothesis is correct because less than, and the deviation is due to the fluctuations sampling due to the random causes. Okay, this is the example of a sampling method. Remember, mean proportion will be this, standard deviation of proportion of success will be this, and precision of the proportion of success will be this. Now for example 3, a group of specific mans reported 1705 sons and 1527 daughters. Do these figures confirm to the hypothesis that the sex ratio is 1 by 2, half? So total number of observation what? This plus this, son plus daughters, total this. The number of sons is 1705. Therefore the observed the male ratio will be male divided by total male divided by total male and female sons, equals to this ratio. On the given hypothesis, the male ratio what? 0.5, that means half. Okay, this is given, but our calculated 0.5275. The difference is what? 0.0275. So the standard deviation of the proportion S equals to this, the formula PQ. P is the half and Q also half, and is the total number of success. So this is the ratio is what? 0.0088. So the difference is more than 3 times of the standard deviation. This is the more ratio is the more than 3 times of the standard deviation. Okay, this is the more smaller. That means this difference is more than 3 times of the standard deviation. Hence it can be definitely said that the figure given do not conform to the hypothesis, because greater than, this is why our estimation is wrong. So this is the standard deviation formula, point estimation. For point estimation, this is this really standard deviation whole square equal to summation x minus x bar whole square divided by n minus 1 for population parameter. Okay, now interval estimation will be this for the 68.27% of confidence level, and this is the 95.45 confidence level, and this is if 3 times then 99.73 confidence level. This is the actually from data. Okay, standard data. X bar and mu s is the mean and standard deviation of the sample. Remember it. So For comparison of a large sample, you have to use these types of formula for that. Suppose example 4, in a sample of 600 men from a certain city, 450 are found to be smokers. In another sample of 900 men from another city, 450 are smokers. Do the data indicate that the cities are significantly different with respect to the habit of smoking among the men? Huh. Which that means N1 is the first sample, total number of men, number of smokers are 450. That means P1 equals to 450 divided by 600, 0.75. First probability. N2 will be the second sample, 900, and P2 will be 0.5. So total P, total probability will be N1 P1 plus N2 P2 divided by N1 plus N2, 0.60. So Q will be what? 1 minus P. Okay, not a smoker. Smoker will be 0.60 and non-smoker will be what? Total probability 1. This is why 1 minus P. 1 minus 0.6 equals to 0.4. Now E error, E square equals to a P1 square plus P2 square. This is given in example. Okay, standard error, E square equals to this formula. Now PQ, this is 1 by 1, N1, 1 by N2. Just putting these values, this is the standard error. Taking a square root of this, we get this. Now Z equals to P1 minus P2 divided by E will be 9.682. Since Z greater than 3, so that the difference is significance. Depending on Z, there are 3 conditions. If Z greater than 3, the difference between P and P will be significant. If Z less than 2, then due to fluctuations of sampling. If Z lies between 2 and 3, the difference is significant at 5% level of significance. We have to remember these 3 conditions. Okay. Similarly, one type of aircraft is found to be developed engine travels in 5 flights out of the total of 100, and another type in 7 flight out of total of 200 flights. Is there a significant difference in the two type of aircraft so far as engine defects are concerned? Actually, N1 is the first sample of first sample, total number of first sample. Number of traveled flights will be are given 5. This is why P1 equals to 5 divided by 100. And N2 is the 200 flight, second flights. So 7 flights. Okay. So P2 equals to 7 by 200. Now error will be, this is the formula for finding error. Taking a square root of this, we get this one. So Z equals to this. Since Z less than 1, Z is less than 1, then difference is not significant. Using what? Using this one. If Z greater than 3, then P1 and P2 is significant. And this is the error formula. Remember it. And this is the Z formula for finding Z statistics. T distribution, actually I have studied about this in our previous lectures. What? Testing of hypothesis. We have studied 4 types of hypothesis. One is Z distribution, then F distribution, then chi-square distributions, then T distributions. 4 types of distributions we have completed. So I am not repeating this here. Okay, this is the end of the sampling. I hope everybody can do this and understand. First of all, you have to concentrate on hypothesis of testing. Previous 3 lectures. If you complete the previous 3 lectures, then you can say that the sampling will be very easy for you. Okay, thank you. Thanks to everybody.